When you experience brain fog, a sudden memory slip, or an involuntary tremor, you are witnessing an electrical miscommunication. Your neurons are physically failing to connect across the brain's vast network. Traditional chemical treatments approach this problem by flooding the entire body. A pill dissolves into the bloodstream, saturating every organ and system just to reach one specific neural pathway, creating heavy collateral side effects along the way. A network engineer solves this differently. By treating the brain as hardware, they bypass the chemistry entirely to hack the electrical grid wirelessly without ever touching the brain tissue. This is photobiomodulation, applying specific wavelengths of near-infrared light to stimulate cellular repair and generate metabolic energy. Think of this light as a physical data packet. Photons penetrate tissue, delivering raw metabolic power directly to the mitochondria, reigniting dim, failing connections on the circuit board. We are no longer limited to treating neurological symptoms with systemic chemicals. We now possess the tools to re-engineer the brain's physical connectivity using exact doses of light. The primary mechanical challenge of delivering light into the brain is the human skull. Bone is thick, dense, and naturally blocks energy from passing through to the delicate tissue underneath. External LED nodes on the scalp target surface-level Brodmann areas, mapped regions controlling motor, memory, or sensory functions. But light traveling through bone dissipates, failing to reach deep subcortical circuits. Projecting light up the nasal cavity bypasses the skull, directly striking deep emotional centers. When you fire these specific transcranial nodes on the surface in perfect sync with the intranasal nodes, you can boot up entire functional networks. You can activate the default mode network, which is the system responsible for organizing your internal thoughts and daydreaming. Or you can shift the active nodes to target the salience network. The salience network is the brain's filtering system, dictating what demands our attention so we can aggressively block out external noise and hyperfocus. By manipulating the physical placement of these light nodes, a user gains highly targeted mechanical control over abstract cognitive states. If the placement of the LEDs dictates where the information goes, the pulse frequency is the software that runs on the hardware. The speed at which the light flashes provides direct instructions for how the brain should behave. Take the alpha frequency, pulsing at 10 Hz. Alpha serves a dual purpose. It can command a hyperactive, anxious brain to calm down, or it can provide a steady, energizing rhythm to a sluggish, slow-moving neural state. Then there is gamma, pulsing at 40 Hz. Gamma acts as the high-speed processor, forcing rapid connectivity between distant nodes to drive states of intense alertness and complex problem-solving. Biological interventions carry strict physical constraints, illustrated by the biphasic dose-response graph. This rule shows an optimal dose provides peak benefits, but exceeding that dose causes the system to crash and the effects to reverse. If you push past that peak, your body will throw error codes. Profound fatigue, irritability, and sudden headaches are direct physical signs that your neural system is overloaded. To prevent system burnout, the operational protocol requires strict moderation. The standard regimen is 6 days of targeted light stimulation, followed by 1 mandatory day of absolute rest. Therapeutic light is an active, demanding intervention. Your cells must expend energy to process the data, meaning precise dosing is required to prevent frying the hardware you are trying to upgrade. The most advanced capability of the system is cross-frequency coupling. This allows you to run 2 entirely different light programs on separate regions of the brain at the exact same time. Here is how that looks in practice. You can run a slow, stabilizing alpha wave to act as a grounded psychological foundation, while simultaneously pulsing a high-frequency gamma wave on top of it. This allows you to process complex, high-level tasks without triggering anxiety. This level of real-time customization shifts the individual's role. You move from a passive patient waiting for a chemical to take effect to an active network architect dictating the exact parameters of your own biology. But engineering a system this complex requires rigorous data collection. You cannot rely on memory. You have to track your exact LED protocols, your daily fatigue levels, and your resulting cognitive outputs. Without tracking these variables, you are blindly throwing light at your head and guessing at the results. When you record the data, you are systematically debugging your own neurology. The control once locked inside a clinical research lab is now accessible at home. The tools to physically re-architect the human mind are sitting directly in the hands of the people using them.